So why has Java introduced a preview feature called Flexible Constructor Bodies? Java is a mature language that a lot of people had figured out. So why this change after so many years of surviving without the feature? And it's a small change, but is it impactful? So let's find out. So first of all, we need to install Java, the right version of Java. And to do this, I use a tool called SDK Man. Now, if you don't know much about this tool, I did make a video about it on my channel. You can check that out if you need, but it is super simple. And in my case, I already have Java 23 installed. So if we type SDK list Java, we can see a whole bunch of versions available, and the three chevrons show you the one that's already installed. And I have Java 23 with Amazon Corretto, which is fine for what we need. So we're almost good to go, except the flexible constructor bodies are a preview feature, meaning that they put features out there for people to try and provide useful feedback. These features can potentially be removed in a future release, so you need to keep that in mind. But we want to know how this works, so it's good for us. So here in IntelliJ, I have a simple Java 23 project with preview features enabled. Now, if I go into my settings, you can see that I have preview features enabled. If I want to switch them off, I just go up here and select SDK default, and they will be switched off. So now that we can see that we've got the right code version, we can start looking at this feature. All right, so let's just set the background a little bit. Before this preview feature in Java 23, in Java, if you had a class, we've got an example class here called class A, and this implicitly extends object, even though you don't have to specify that. The first statement in a constructor must be a call to super, which is a call to the parent constructor, or it must be a call to this, which is a call to another constructor in the same class. So here you have a call to super. You don't have to put that in because it's implicit. And instead of that, you could have a call to this, which would call this constructor here, and that constructor would then call super. Now here you can see that we don't call super or this, but you'll find that there is an implicit super call pasted in here, even though you don't see it. Java just does that for you. So that's the kind of basis. Now, if we've got an example where there's a parent class that's extended by a child class, ones that we've created, so not extending object, although this does extend object, but here we've got a class which we've created, extending a class which we've created. And here you can see that there's a parent constructor. You can also see that the child constructor has a call to super. Again, this is implicit. Now here in the child constructor, we've added a call to this, but an important distinction between this and super is that the call to this is not implicit. So if you don't include it, the compiler will add a super call, not a this call. So that's just the basis of how constructors work in Java. Now let's take a look at what the problem is. So in this example here, we have a parent class with a constructor that calls the do something method. Now do something in the parent class doesn't do anything, so it's perfectly safe. But in the child class that extends parent, we have a constructor that takes two values. It tries to set active to false, but that is not allowed without the flexible constructor bodies preview feature. And the first call has to be a call to super. That's why you can see these errors here. So let's just hover over that. Can't reference child.active before superclass constructor is called. Now, the reason why we wanted to do that is because we know that the parent constructor is going to call the do something method. And when it calls the do something method, this is potentially doing something destructive. Now, obviously, it's just a print statement for the purposes of our demo, but imagine this is doing something that could potentially move some files around or do something destructive, and you want to put a guard around it. So we only want to run that if it's active. We want to set active to false. As you can see, that wouldn't be possible without this preview feature. It would have to come with some kind of workaround. So if we enable the preview features now, you can see that now that we can get around with that and we don't get any errors, we can set active to false, which means that when super is called, this parent constructor, it hits do something is overridden. It checks the active flag and only does the destructive operation if active is true, but we've set active to false. Okay, so this demonstrates one of the kinds of problems that you might face with constructors before this preview feature. All right, so let's take a little more look at the problem that we're trying to solve here. So we'll take a look at this problem class here. Now here we're trying to solve the same problem, but in a slightly different way. We've got the parent class with the parent constructor calling do something. And do something again is empty in the parent constructor. Now child2 extends parent. We'll come back to this bit here in a second. You can see that we've got a constructor here which has got nothing in it, which means that it'll automatically get a call to super. Super, when that's called, that'll hit the do something method, which is overridden, and that'll run this piece of code here. And again, we've got the same problem that we're trying to solve, where you only want to execute this code if it's active. Now, because we can't set it before super without this preview feature, we can declare a static variable. And then we can set the value of that to false in this static block. Now, what's the problem with this solution? Now, the biggest problem with this solution is that if we want to have it so that it's specific to a particular situation when the class is constructed, you can't really do that because it's static and therefore it's once per class load. So that's the biggest limitation with this approach. Now, let's see if we can get around this with a different approach. So we'll jump to our next problem class. Now, if we look at this, you can see that we've got a very similar setup to before. We've got another child class which extends parent. We'll come back to all of this stuff in a second. You've got one child constructor there, and you've got another child constructor here, and you've got the same setup with the do something method. Now, this is per instance because this is not a static block. Now, if you contrast that with this, you can see that this is a static block. This is not a static block, it's an instance block. So this kind of gets around the once per class load problem. However, you can't really set it specifically to your class because you might want a different value if it's constructed via this constructor, and you might want to set it to say true if it's constructed via this constructor, but you can't do that because you need that to execute before the call to super, and without this preview feature, the call to super has to be the first thing in the constructor. So it kind of feels like it might have got us past the static solution, but in reality this doesn't get us much further along. All right, so let's have a look at one final example of a problem with the current approach. So we'll jump to this class here. Now here we have an example of a parent constructor which takes a value, and in the child class where we extend parent, now this is currently not erroring because we've got preview features enabled. If I just switch those off, you can see that it starts to error again because super needs to be the first line in the constructor. And if you see, the way that we could work around this is by doing this and just commenting these out. And you can see that you've got an inline construction of this value. But sometimes building up these values in the constructor arguments isn't really what you want. And this would have been a more elegant solution. And remember, this could get much more complicated. You could build up these objects here, but you have to do all of that inline in the arguments to super, which is not very pleasant, especially if you have more than one. So let's re-enable preview features. And you can see that we can do any kind of complex object construction. We can even call out to static methods to build those values and then pass them to the super constructor. Okay, so let's jump to a quick recap. So before this preview feature, the constructor's first statement must either be a call to super or this. You could not place any other statements before these calls. This restriction meant that your initialization logic was sometimes forced into static initializers that we saw, or instance initializers, or post-construction methods. They also meant that if you needed to pass a complex value to super or this, you had to compute it directly in the call, which can be a bit untidy. The Flexible Constructor Bodies feature introduced as per JEP 482 relaxes this rule and allows developers to write code before super or this. So let's take a more detailed look at it in action. So first up, let's have a look at complex computed values. You have a constructor here in the parent class, which takes a value. Now in the old style, before Flexible Constructor Bodies, we couldn't do something like this, followed by a call to super. We had to actually inline that, but now we can do something like this. And we can comment this out. And you can see that that compiles absolutely fine. And there's another example here of where it can get even more complicated, and you can call super absolutely fine. So let's take a look at some more examples. Now here we have an example of a complex parent that takes two arguments. We want to compute them, and we have plenty of computation logic here, which is conditional. It builds up the config and then calls super, passing it the appropriate config. Now all of this section here wouldn't be allowed prior to Flexible Constructor Bodies. Now you can do all of that logic exactly where it belongs and call the super constructor as appropriate. Right, let's take a look at another example. Now, one thing I just wanted to quickly highlight, because I'm not sure if I mentioned it earlier, is that the call to super is implicit. That means if you don't add it yourself, it will automatically be inserted, okay? But the call to this is not implicit, so you don't get an implicit call to this. In this case, if we had not included this call, you would have got a call to super instead. So super is implicit, this is not. All right, so hopefully that was a useful recap about how constructors work, and you got a useful insight into how Flexible Constructor Bodies might help solve some of these minor niggles that we've had to deal with in Java for a long time. By the way, I'm Saeed, the Codogrammer, and if you find this content useful, it's super helpful if you're not already subscribed that you do so. It really helps us produce more content like this. Now, coming back to Flexible Constructor Bodies, if you want to know more about this feature, I definitely recommend watching this video with Venkat Subramaniam and JetBrains. They go into a lot of detail on this topic. As always, let me know what you think in the comments below, and if you don't want to be the last to know about important AI tech and programming news, then be sure to hit subscribe. Thank you for watching.